All right, 21. We're looking at a function talking about a relative max or a min of that function. So we need to find the derivative. F prime is 3x squared minus 1. You need to find the 0. So set it equal to 0. X squared equals 1, so x is plus or minus, that's 1/3, plus or minus square root of 1/3, which is root 3 over 3. So we're going to have negative root 3 over 3 and root 3 over 3. Remember, we're plugging into f prime. So when we plug in something below negative root 3 over 3, which is like negative 1, okay, then this is going to be positive. If you plug in something in between like 0, it's negative. And then something after root 3, so like 1 would be positive. So that means you have a local max at negative root 3 over 3 and a local min at root 3 over 3, which is B, a relative min. All right, 22. On what interval is the graph concave up? So what I'm going to do first is multiply this out. That gives you 2x to the 6th minus 15x to the 4th. So that is f, okay? So f prime is 12x to the 5th minus 60x to the 3rd. And to look at concave up, we need the second derivative. So f double prime is 60x to the 4th minus 180x squared. We can take a 60x squared out. You're left with x squared minus 3. When you set it equal to 0, you get 0 and plus or minus root 3. We're looking for concave up. So if we plug in, so we have negative root 3, 0, and root 3, and remember we're plugging into f double prime because we're looking at concavity. If you plug in negative 2, that's going to be positive. If you plug in negative 1, that's going to be negative. If you plug in positive 1, it's also negative. And if you plug in 2, that is positive. So you are concave up before negative root 3 and after 3, which is E. Okay? And then 23, we have a function is continuous and has a local min at 1,8, which must also be true. So at the point 1,8, you have a local minimum. Okay? So that tells us nothing about the derivative of 2. It tells us nothing that f prime exists at 2. The graph is concave down at 1. If we have a local minimum at 1,8, the graph would not be concave down, the graph would be concave up. Okay? And then let's see, f prime is less than 0 if x is less than 1, and greater than 0 if x is greater than 1. To have a local min of a function, f prime, the derivative would be negative before it and positive after it. So that answer is D.